Dr. Clokey, thank you very much for agreeing to do the interview today. So, could you tell us why you chose to research phage therapy?
Yes, you're welcome. It's nice to have the opportunity to talk to you.
So, why has this concept not been used commercially before?
And after this early success, there are a lot of very entrepreneurial businesses that set up companies to exploit bacteriophages. And there were several reasons why they failed, but the main, credibility. So the companies often over-egged the custard. They said that the phages could cure all sorts of things that they couldn't, such as viruses and eczema and all sorts of things that there's no way that bacteriophages could be effective for. So there was overinflated claims, there were difficulties associated with making a stable product that could be quality controlled. And also the problem with the bacteriophages in general, especially at this time period, is that they were because they're so specific, as soon as antibiotics came on the scene, they were just seen as commercially much more preferable. One antibiotic could be used to treat many different bacterial diseases, and bacteriophages were considered as being too specific along with those other problems.
What are your hopes for the system that you're working on at the moment?
So my research has focused on bacteriophages that infect Clostridium difficile. Now this is a very important gut pathogen, the most common cause of infectious bacteria caused diarrhea in the UK and in the Western world. And because it has a complicated relationship with antibiotics, it is very difficult to treat. So what we're hoping to do with bacteriophages is produce an alternative option for doctors to be able to treat patients who have Clostridium difficile infection. So where we are with the research at the moment is that we've identified in my lab a whole set of bacteriophages that infect most of the clinically relevant strains of Clostridium difficile. And now what we're doing in collaboration with a company who's helping fund this research is testing to make sure that they work well as a combination, but both in just in flasks and in broth and culture, but also in more complicated models to check they work well as a combination. Now, if all that goes well and they work in model systems, we're hoping to go through into clinical trials, starting with phase 1 and phase 2, and the company intend to promote the product to the end. So ultimately, hopefully, you would have a little bacteriophage product, probably encapsulated, that you would take when you were ill in hospital with Clostridium difficile.
So in the article that we read, we understood that the phage is only effective in about 90% of C. diff. Why is that?
So bacteriophages are very specific. So they're specific to the species in general, and then within that, they're often just specific to certain strains of species. So Clostridium difficile is it's very good at evolving. There are many different substrains of it, subtypes of it. So up to, I think, more than 450 recognised strains of Clostridium difficile. Now, what determines a successful interaction and a successful killing is quite complicated, but essentially, what we try to do is identify bacteriophages that can kill many strains. Okay, but we don't want to have a product that's got lots and lots of bacteriophages in them, because that's difficult to check and to monitor and to control. So ideally, we would have a product that killed everything. But what we can do, the point that we aim for is for the bacteriophages to be able to kill 90%. It's sort of the sweet spot, because hopefully, with just perhaps 3 or 4 viruses, we should be able to kill that number. We'll make sure that we have phages that kill the dominant strains. So although it's only 90% of the strains, it's probably more than 95 or 98% of the abundant strains.
What other bacteria do you think that phage therapy can be used for, aside from these various different strains of C. diff?
I think bacteriophages can be used for a number of different bacterial infections. The main drivers are going to be clearly where we have bacteria where we have no more options for, which are either resistant to most or all antibiotics that we have available to us. So, for example, there's a group of bacteria, gram-negative bacteria, known as extreme drug-resistant bacteria. It includes things like Pseudomonas aeruginosa, Klebsiella pneumoniae, and Acinetobacter. Now, all of these bacteria are very difficult to treat. They're just naturally resistant, and they've acquired resistance. So they would be perfect candidates for bacteriophage therapy, because how else are we going to treat these bacterial diseases? There's another set of bacteria I think that'd be useful for, and that's where you have bacteria that are not resistant to antibiotics, but they're very difficult to access. For example, deep bone infections are difficult actually to get antibiotics to, and the advantage of a bacteriophage would be once you can get one bacteriophage or a few bacteriophages to that site of infection, the bacteriophage will then replicate and clear that infection. So I think the biggest driver are where we have problems with antibiotics or where the diseases are complicated to treat.
Why do you think phage therapy has not become more global yet?
Well, until recently, we've really had our head in the sands about the problems with antibiotic resistance. So for 50 years we've just used them fairly widely and casually. And then there's a recent sort of growing awareness now that actually we can't keep doing this. So because antibiotics were always seen as the driver, that there was really a massive dearth of research on bacteriophages. And until about a decade ago, it was a very unattractive area for scientists to research. There was no funding available. It was just seen as something that some crazy Eastern Europeans tried. It didn't work. So it suffered from the bad press associated with the early days. So there's now a sort of lag time for the sort of phage community, particularly the bacteriophage therapy community, to sort of re-energise and regroup and focus on specific groups, and then form liaisons both with people who always carried on using bacteriophage therapy, such as the Georgians, and also other biotechnology companies who are interested in pushing this technology forward.
So the Chief Medical Officer for the UK has called for antibiotic resistance to be considered on par with terrorism. How much do you agree with that statement?
Well, I absolutely agree with it. What she pointed out was a sort of harsh reality that it could be that you go into hospital for something either routine or some form of surgery, and you recover from that. But what happens when you're in there is you get a bacterial infection that can't be treated with antibiotics. It's a very, very serious situation that we're in at the moment, and hopefully bacteriophages could be one of a new set of unexplored weaponry that we can use against these antibiotic-resistant bacteria.
Thank you very much, Dr. Quakey.
You're welcome.
So why did you choose to go into phage therapy research? Why has this research not been applied commercially yet? In the article about your research, we read that the phage is only effective in about 90% of C. diff. Why is that? So obviously this research has not become very global yet. Why do you think it's not spread very far?
So I spent a long time looking at bacteria that are very important in the oceans and how bacteriophages controlled them and manipulated them and how they affected their dynamics. And through doing this work, I realised that it would be very interesting to take a similar approach and actually see if we could do a sort of environmental work, but on bacteria that cause problems to humans. So therefore this spurned an early interest of mine in bacteriophage therapy.